ladies and gentlemen,
The crap.
I have 1, 2, 3, 4, 5, 6-ish rows. Okay, row number 1. You guys should know how to do this. N plus 1 quantity squared. Can somebody tell me what that equals? Carlos, there, not unless you can't see. You guys need to sit in your appropriate seats. Okay, that's what I need to know. N plus 1 times N plus 1. And then what do we do here? We FOIL, correct? Or the distributed process, however you want to do it. Row 1, this is your baby. Go at it. Row 2, that's you guys. You guys are going to do N minus 8 quantity squared. It's not. Okay, this row, you're going to do N plus 3 quantity squared. This row, you're doing N minus 5. This row, N plus minus 4. You guys and you too. You guys are going to go N minus plus 3, not 3. What number am I at? 1, 3. We'll make it a 12 because I like you guys. That's a 12. Ridge! This, if I write it on the board, it's a good thing you write it on the board. Get N squared plus 2N plus 1, correct? Row 2, what did you get?
N squared minus 16 and minus 64.
Minus? Plus 64, because anytime you square something, it becomes positive. Third row. N squared. You didn't do it, did you, you slacker?
I tried.
You didn't even try. Foil. Distributing. What'd you get? Go. Plus 6N. Awesome. You got her. Excellent. Okay. How about this one? What'd you guys get?
N squared minus 10N plus 25.
Do we see a pattern?
No.
No patterns?
Yeah.
Okay, hold on. We're going to wait till the last one and hook you guys up. What did you guys get? N squared minus 8N plus 16. Awesome. Do we see a pattern? Okay, last group, what did you get? Let's see if it... okay, I bet you guys have it. Anybody over here that sees the pattern, raise their hand. Megan, go. Tell me what you believe it's going to be. So I'm going to have what? N squared minus 24N. You know your 12 times 12? 144. You didn't even have to do that. She didn't do that, and she found it out just like that.
I'll do plus 24.
Oh, is it a plus? Sorry. I thought it was a minus myself. Apologize. Okay. Here's the pattern, ladies and gentlemen. See this value right here? Doubles to get to there. 1 times 2 is 2. 1 times 1 is 1. 8, negative 8 times 2 is negative 16. Negative 8 squared becomes 64. 3 doubled becomes 6. 3 squared becomes 9. Does everybody see that? You see the pattern. Notice looking at this guy. Negative 4 times 2 is negative 8. Negative 4 squared becomes 16. Any questions on the pattern? The pattern is essential today. If you have, I really need everybody to understand the pattern. Carlos. Yep, you just times this number by 2, and then you square that number for the third term. This is not your homework. Is there a part of this to be your homework? A little bit, yes. Okay, you guys ready? I'm being serious. Does anyone really not see the pattern after I've explained it? Because if you don't understand the pattern, today is just gone. Because this is what we're using the whole day today. Okay? This is called a perfect square trinomial. This is called a binomial squared. Notice it's the same thing as a binomial times itself, right? A binomial squared will always go into a perfect square trinomial. Okay? So, question. What if I write this? What goes there? Say it in your head first before you shout it out. Okay? Think about it, think about it, think about the pattern. if it is a perfect square trinomial, what should go there? Give me 1 second. Give it some time to people. What do you got for me? 144? Not quite. Not quite. Kenzie. It would be 36. Can you explain your thinking process to me, please, Kenzie? Negative 6 times 2 becomes negative 12, remember? So we're technically asking, okay, we know this is going to be an n, right? Does that make sense? Math, right? Okay. And then we say to ourselves, remember, whatever number here, when I times it by 2, becomes this number. So that would have been a negative 6, correct? As Mackenzie said. And then what do you do to find that last number? You square this negative 6 become 36. Does everybody see that pattern? Once again, you cut the middle term in half, because that gives us this one. Because remember, this times 2 got us here, and this squared got me. That was interesting. Okay, does everybody understand that? We're going to do another one. Okay, so let's say I had n squared. Does it have to be n? Could it be x? Could it be m? Could it be p? Yeah, sure. Plus, let's say 20 n blank. What goes in the blank again? One second, I want people to think. What goes in the blank? Go ahead, Bryson. 100. Explain, Bryson. 10 times 2 is 20, so therefore this would have been n plus 10 quantity squared to make it this perfect square trinomial, right? This divided by 2 is 10. Gentlemen, do you need help, Tate? Austin? Okay. Cut him in half, that gives you this number. This squared goes here. So therefore that's 100. Good job, Bryson. Alex, do the same thing? Yeah. Goobler, you good? Or not Goobler? Mr. Gear, you good? Awesome. Ethan, you on it? Yes, sir. Yep. Exactly. Does everybody see the pattern? It's important to see the pattern. Okay, here we go. We're doing our first real problem. This is what we're doing today. Y equals x squared plus 4x plus 3. Is that guy in a perfect square trinomial? Okay, Mr. Peterson, why is this not in a perfect square trinomial? What would need to be instead of that 3 there?
It would need to be 4.
Does everybody understand why it would need to be a 4 if it was a perfect square trinomial? Because we cut this guy in half, which would have became 2, then we square him, a 4. Okay, so that is it. Our goal today, ladies and gentlemen, if you remember, this is called standard form, right? What's the other form that we learned? We are putting standard form into vertex form today. That is our goal. It's really simple. Do you understand the pattern? I'm being honest with you. Do you understand? It's not hard. Okay, you ready? Watch what I'm going to do. We're going to do it right now. I'm not. By putting that parenthesis in, did I change the value of that problem? Did I?
No.
I didn't. Tyler, what should go in there to make this a perfect square trinomial? What did you say it should go in there? Ignore him right now. We're just filling the blank like we just did. It needs to be a plus 4, doesn't it? I'm sure it doesn't. Okay, this is the only thing that's a little bit you have to think about. What does an equal sign mean to us? Anybody tell me what an equal sign means? No, it doesn't have to solve. They have the same value. Our y, it's like a teeter-totter, right? Does that make sense? Our y's over here, here's our function or our equation over here. What just happened to this side? What did I add to it? I put a 4 on this side, didn't I? So I went, So what would I need to do to balance it out without touching this side? I do not want to touch this side. What do I need to do, Savannah? I need to minus a 4. Does that make sense to everyone? Because I put a plus 4? to keep me balanced, I need to minus 4. Yes or no? Yes or no? Does that make sense? Okay,
Kind of.
Jax, you good? Because once again, look at my teeter-totter. Plus 4 got me heavy, right? So all of a sudden we had to take off like 4 pounds to get me back even on this same side. So if I added 4 pounds, I have to subtract 4 pounds, right? Does that make sense? What I think about is you two, okay? Really, think about this. Let's say you're your mom and dad. And who's bigger out of your mom and dad? Be realistic with me. Is your dad larger than your mom? Weight-wise, you would think. Let's say yes. Okay. So right now, if it was just the dad and the mom, okay, dad would probably be heavier, right? Does that make sense? Okay, so let's say Kalisha gets on to even them back out. Maybe she's the difference in between dad and mom. Okay? So now we're even. Dad's over here, mom and Kalisha's over here. Okay? And then Kira hops on this side as well. I got the name right? Okay. Getting a little nervous every now and then. So what happens? Now I got 2 twins and mom on this side. What happens? I get heavy. But it's now Kira's time, so who has to get off? Kalisha does, because if you add a twin, you gotta subtract a twin, right? Does that make sense? That's kind of my analogy. I don't know if that works for you, but hopefully that makes sense. Okay? Perfect. Okay. So, what does this guy become? What does this guy become? We just did it. It became what? X plus 2, right? And then what's 3 minus 4? Is that hard? Be honest with me. Is that hard? Okay, where did I lose you then? I want to make sure you're good. It is a little bit complicated, but the thing that I notice on what I did yesterday in factoring, and what I'm doing today is I'm not changing the values, correct? I'm not changing the values, I'm making them look different. That's all I'm doing. Yes, sir. Okay, so remember, looking at this pattern that we did over here, okay, so I'm at this stage right here. I just made it perfect. So how did I get to this 2? Is remember you cut this guy in half. That's going to be it. Does that make sense? So for us, I think I had a 2. Nope, I never put a 2 one up there. But I cut, it was a 4. We had a 4 one. Nope, we don't. But you understand I have a 4 here, so I cut him in half. That's the 2. And notice how did I get this 4? Because I cut him in half. That is the 2, and 2 squared equals 1. You okay with that? Good. I'll put it back. This guy? This is a perfect square trinomial. It had this pattern. Correct? Didn't have this pattern. And if it has this pattern, I can go back to the binomial square. That's where it went. If I truly factored that, like what we did last time, it would come out to be n minus 2, n minus, or is it plus? Plus. It'd be n plus 2, n plus 2. So hence, n plus 2 squared. Do you understand the pattern? Yes or no? Okay, so notice I'm going from this to this, because isn't this equal to this? Do you understand that? So therefore, can I go backwards? That's what I did. That make sense? Look right here, one more time. I had that pattern, so I went from my trinomial back into my binomial. That's all I did, because of the pattern. 2 squared is 4. Excuse me, 2 times 2 is 4. 2 squared is 4 as well. Because I went from the trinomial back to the binomial. Go again? Like, what's 3 minus 4? Because I had to balance it. Because if I put a plus 4 here, it changed the equation, didn't it? So therefore, to balance it, let me show you this, okay? If I had x squared plus 4x plus 3 plus 4 minus 4, what's this? 0. So did I change the value of what I had originally? But notice I need that plus 4 next to these guys so I can go into my binomial square, right? And so therefore, then I just move this plus 4 instead of here because of the commutative property, right? I can move 3 plus 4, 4 plus 3, the same thing. here. How did I get this 4x? Do you the key thing, guys, I'm being honest, do you see the pattern? Okay, so it's right now in this pattern. X squared plus 4x plus 4 is in the pattern, right? What is the value that made this? 2. Right? So therefore I went from my trinomial to my binomial. So I went from here to this one. Is that what your question was? No, we're starting in this kind of form and trying to get back to this form. Where was it after? Do you remember who it was after? Okay. All right, let's try another one. Maybe another one will help you guys out a little better, okay? Everybody with me? Let's do another one. Here we go. Is that in a perfect square trinomial form? No, it's not. Can somebody tell me, instead of the -1, what should be there? A 9 should be there, huh? Does everybody understand why a 9 should be there, if it was in a perfect form? Yeah. Okay, so you're struggling with that, right, Carlos? Okay, so looking at the pattern, remember, to get to a perfect square trinomial, whatever is half of him, and then I square it, should be here. So Carlos, looking back at this problem, oops, what's half of 6? 3, and 3 squared would be 9. So a 9 should be here, correct? If it was a perfect square trinomial. Well, once again, I just want to change this form into vertex form. I don't want to change the values, correct? Key thing, I don't want to change the values. I just want it to be a little bit different. So I group the first guy. I didn't change the value by just plugging parentheses in there, did I? No. So once again, Carlos, to make this guy perfect, what needs to go here? What did we just discuss needs to be here? A 9, because we cut him in half, right? And square him, that should be a 9. Hogan, you okay with that? Austin, you okay with that? Ridge, you okay with that? Okay, balancing time. We just switched our equation, didn't we? We just added 9 to this side, correct? So what do we need to do to get back balanced? I need to subtract 9 out here to get me back balanced, correct? Does everybody understand the balancing beam? Hence why I put a +9 here. My next problem is going to be a little bit different, but hopefully you'll see it. Okay? Now, this holds the pattern that we looked at today. This is a perfect square trinomial, correct? Some of you guys had problems here. So is this in that pattern? That's the perfect square trinomial. So I can go into my binomial squared because it has that. So I'm taking that trinomial back in to the binomial, right? And what is that binomial going to be? X plus 3, because that is the half value of him and the square root of him, right? It has that pattern. Good with that? Hogan? We're going to work it. We haven't got there yet. What's -1 minus 9? So what's my vertex here, ladies and gentlemen, from a couple days ago? What would have been my vertex? -3, -10. The x squared, that's once again, if I watch, okay, I'm going to hurry and I'm going to go fast through it, okay? Just watch. X squared plus 6x plus 9, factors of 1 times 9 is 1 and 9, 3 and 3. Those guys get me to 6, okay? X squared plus 3x plus 3x. You should hopefully know the factoring today. Group, that guy has an x, x plus 3. What do these guys have in common? A 3. I'm left with x plus 3. So notice that factors to be x plus 3, x plus 3, which is x plus 3 squared. I am skipping the FOILing because we see the pattern. Because of the pattern, I know I can take this perfect square trinomial into the binomial square. Does that make sense what I'm saying? Okay. Yes? It should be. Of the other number, exactly. If that's a perfect square trinomial, that was our pattern, wasn't it? Exactly. Okay, I'm going to throw you for a loop on this one. This one's a little bit deeper. Okay, and as soon as you see it, hopefully you understand. First off, we can't tell whether this is a perfect square trinomial or not. Why? Because we have only been doing them with coefficients of 1, right? And we have a coefficient of -2. We see that. Okay, you do the same step at first. Same step. Okay, did I change the value by putting my parentheses in? No, I didn't, right? What number has to be here for me to do my perfect square trinomial? A 1. How do I make this -2 a 1? I factor it out. All I did is I factored out that -2. That's all I did. If I distributed it back in, would I not get back to this? -2 times x squared, -2x squared. -2 times -6 becomes a +12, which is exactly what we have. So if you have a coefficient other than 1, you need to factor it out. What if they don't share? Like 12 and 2, they both have a 2 in common, don't they? What if they don't have something in common? You still factor it out? Yep, you do. Maybe we're not going to get that deep, but yes, you do. Okay? Is everybody okay there? This one's very similar to what we did the last time. What goes to complete the square? This is the only thing I'm caring about right here. I need to put a 9 in here, right? Everybody there with me? Maddie, you good? Miss Witten? You good? Miss King? Okay. All right, balance beam. I just put a +9 on this side. What do? No. I cannot. Because of the -2. Because truly, what did I put here? I didn't put 9. I put -18. True? If I distributed this back, watch what I do here. If I distribute this back, I get -2x squared plus 12x minus 18 plus 1. From my original equation, what did I add? Because I did a minus 18, what would I do? Yes, I would. I would add the 18. Okay, so what's the difference? Why on these guys could I just do exactly what I put in there? Because what's the factor number out here? There's a 1, right? So therefore, 1 times that 9 was a 9. Huh. So therefore, I could just balance it with a 9. Okay, but here, because this is technically a -18, I have to balance it by adding 18 because he was already negative. Yes, no, we see that. I'll tell you that's the biggest people forget about that is that problem right there. Okay? I'm going to erase this real quick. Get us back to where we are at. But do you see why I'm doing a -18? That's technically a -18. So for balancing purposes, I have to add 18. Right? Okay. So last but not least, I just leave this -2 out here. Scroll up a little bit. What does this guy become? Is this our perfect square trinomial? Does it work, Jesse? So what goes into here? What is it going to be? Hold on, I'm going to let Jesse try. I want to see if you can do it for me, if that's okay. If you're all right with that, Jesse. You got it. We just cut him in half. -3 is cut this guy in half. Square root of 9 is 3, but it needs to be negative because the middle term is negative, right? James, you good? Jake, you good? You good, Megan? Nope, not yet. What's -1 plus 18? Plus 17. Does that make sense to you? Good. That's just, I don't want to change the value. Was there a -2 originally? I don't want to change that value. I just want to make it look different. Okay? First up, Becca, come here, please. Becca's going to hand out your homework. By the way, on here it says solve. Please just, okay, let me show you what your homework looks like really quick. I'm going to do one off your homework. I know. Hey, this is what your homework looks like. This wasn't exactly what we wanted, but it's going to work, okay? So what you want to do is get everything to one side. Is everything on one side? What's probably the easiest thing for us to do? Subtracting this 2n over, right? Does that make sense? Okay, so I have y equals negative 2n squared minus 20n minus 32. That's what I kind of want you to do. Get everything to one side and then complete the square. Can you do that for me? The homework was, when we were building it, we just thought of solving. That's coming up. Okay? Alright, keep your notes out. This is a good one to keep looking at. Don't do it on that because you want to practice it later. Okay, is this a perfect square trinomial? No, especially because of him, right? So negative 2n squared minus 20n minus 32. What do I have to factor out? The negative 2, correct? Right, Hunter? Are you okay with that? You don't know why we have to do that. Because remember, it's always a 1 right here. Was he a 1? So what can I do? Just factor him out. So that becomes an n squared plus 10n. Are you okay with that? Did I change the value by pulling out a negative 2? No! No! I did it! Did it! Okay. You're awesome. I love you. Okay. What goes in to make it completing the square, Hunter? Half him, so that's going to be 5, and 5 squared is going to be awesome. Are you okay with that? So what do I actually put out here? Close. What does that truly become? Negative 50, so therefore to balance a negative 50, I need to add 50. Carlos. Because I factored out a negative 2. Because didn't I factor it out? I have to factor it out of both of them. Are you okay with that, Carlos? Maggie, you good? Or are you still on Instagram? And on Instagram. Oh, all right. Anyway. Okay, so we balanced, right? Okay, do you guys understand where the 50 came in? Okay, so therefore this is negative 2. And as Jesse said, if the pattern's been following, right, this should be n plus 5 quantity squared plus 18. Ladies and gentlemen, that's all I'm asking you to do today, is taking something from standard form and putting it into vertex form. Thank you. If you have questions... It's somewhere. Okay, it's behind. Oh, hi, we're recording. What are we recording? Did I never stop my recording?